All right, Algebra 2, welcome back, guys. We are jumping into Section 2 today. All right, so Chapter 2, Section 2, titled Proportional Reasoning. And let's go ahead and get the page number up here. It's page 97. All right, page 97. Okay, so you guys got to have your textbooks open. All right, these notes are going to be very, very important. And you can't get through these notes without your textbook because the example problems come directly from the textbook. They're word problems. You need to be seeing what I'm seeing to go through this, okay? So I'm telling you right now, these notes are vital. And it's probably going to start to become something where if you've gotten away with not needing to watch these videos, that's going to fizzle away. All right, you're going to need to watch these videos and pay close attention. So let's jump into it. Okay, you got 5 key terms. And these key terms, again, you got to define them. You got to, at the minimum, write them down into your notes. If you want to memorize them, you're just ahead of the game. Okay? All right, the next thing is you got to copy that little chart that's on page 97. It's kind of a nice little review, refresher of what solving proportions looks like. Okay, so let's jump into exactly what that means. You will be cross-multiplying to solve proportions. Okay, so the textbook, they give you an example of it. I will be giving you another example of it so you can follow along with the book and me. And the next thing is look real closely at example 3 to get this idea of what a conversion proportion looks like. Okay, we're going to be going through another example together, but the textbook example is great, and we use that textbook example to flow into our own example. All right, so pay close attention to that and read example 3. All right, if you don't get it the first time, read it again. Pay close attention. All right, little review here on geometry. Everybody loves going back in time and reviewing that. So quick thing here, shapes are similar if they fit these parameters, okay? The angle measures have to be equal, in other words, congruent, okay? So the next thing is that the side lengths are in proportion, okay? So what I mean by that is, let's say one side length is 6, and the other shape has a side length of 3, then they are in proportion based upon they are half the length. But that would be every single side has to be in that proportion. Okay, so if you have a side that's 8, then maybe the similar side on the other shape is 4, because again, it could be cut in half. All right, but the thing that has to be equal is the angle measurements. So all the angle measurements from one shape has to equal the other angle measurements on the other shape, okay? And I believe, I think it's example 4 in these notes that will cover that concept. Okay, let's jump into it. First example, very straightforward. Remember, we can use our calculators here, so let's do some calculations. All right, so the colors, let's change this up. Cross multiply, okay? Boom, boom. All right, there you go. So you got x being multiplied by 84, giving us 84x. 77 being multiplied by 12 gives us 924. Okay, final step. Divide both sides by 84 because we want to get x totally by itself. 924 divided by 84, giving you exactly 11. Okay, x equals 11. And there we go. So that's our nice little intro, proportions, cross multiply, reduce, solve, boom, there we go. Okay, now we take an immediate step up. CIO stands for check it out. So we are going to all be on, as it says, page 98. Take a look at check it out number 2. All right, so it says at Clay High School, 434 students, or 35% of the students. So what that means is that 434 students is 35% of the school population. Okay, So 434 is 35% of total. Okay, so we're given that right there. They play a sport. How many students does Clay High School have? Okay, we could create a proportion simply from this. All right, you could create also an algebraic expression. Big old fancy words for just you could create an equation and solve, or you could create a proportion. And since this whole section is kind of based upon proportions, let's take that route. All right, so you have 434 students over X because that's the total and we don't know it. So you have part over the whole, and we don't know what that whole population is. Then you got this word is here, so that stands for equals. And then we do know that 35 over 100 would work because 35%, what do we always base percents out of? 100. So there we have our proportion. And now you simply cross multiply and solve. 35x equals 43400. And now the final piece here, we just need to divide both sides by 35. That way we isolate x, our variable. Okay. And let's see, 43400 divided by 35, giving us 1,240. So that right there, that's our total school population because they gave us at the beginning that 35% of it, in other words, 434 play sports. Okay, you guys don't forget, if you are not tracking with me, then pause it, rewind it, go back, rewatch it. Okay, that's a benefit of these videos. All right, so don't waste those opportunities. Okay, let's move down. Here we go. Now, example 3, pay close attention. Okay, so we have check it out number 3, page 98. If you have not read example 3 yet, pause the video right now and read example 3. Okay, because we're going to do this problem based upon how example 3 was conducted. All right, so here we go. Okay, so our problem says that Lewis ran the same 400-meter track in 297 strides. We will need to find his stride length in inches. All right, so again, basing this all off of the example 3, because it's just a continuation of that style of problem. So let's do this. Let's create a proportion that will do 2 things. All right, first thing, we're going to have that this is a 400-meter track over the fact that we know this guy, Lewis, can do that in 297 strides. Okay, and then we're going to set this equal to an unknown meter length, so x meters, over 1 stride. Okay, we need to start by determining how many meters is 1 stride. Then from there, do a conversion from meters into inches. Okay, which by the way, it doesn't work out so perfectly because meters, that's the metric system. Inches, that's the customary or standard system. So those conversions never tend to work perfectly. We're going to get some decimals. We may have to do some estimating. Okay, so let's proceed. All right. Simply, you could cross multiply, but I want you to notice something. Right here, you just have the number 1. All right. That means that if you cross multiply, it's kind of like one little added unnecessary step. So what I would simply do is this part right here. Just divide it. Plug that into the calculator. 400 divided by 297. And that's going to give you 1.34. And it does keep going. But the 1.34, and then there's a 6. So what I'm going to do is I'm now going to say 1.34 1.35 because we're going to round it up. And I always want you guys to keep 2 decimal places. Okay, so you got tenths, then hundreds, and I'm good with that, unless the textbook specifies that they want 3, but for me, 2, we're good. Okay, so that means we have 1.35 meters per stride. Okay, so every single stride, that basically means when he's running, that one full step is 1.35 meters. Okay, now comes the conversion of taking 1.35 meters and figuring out how many inches that is. Okay, so let's write up that proportion. 1.35 meters over 1 stride is going to be multiplied, because here's the conversion. And in example 3, they give you this number, 39.37 inches. Okay, I didn't magically create that. That's why you got to read example 3. 39.37 inches is what 1 meter is in inches. So underneath that, we're going to put 1 meter. Okay, and now the reason why we set this up just like this is because we want to cross out meters, and if they are on opposite sides, like meaning top and bottom of a proportion, you can cross out units, and strides is not really a unit. So what are the units we're going to be left with? Inches, which is what we want. You'll be left with inches per stride, which is exactly what they're asking for. You'll see that you have the numbers 1 and 1 on the bottom in your denominators. So 1 times 1 is 1. That kind of negates itself. We don't care. We also know this is going to be an approximate, okay, because we're messing with decimals here. So take 1.35 and multiply it by 39.37, and you will get the approximate 53 inches per stride. And that, my friends, is the solution to that question. All right, so that could be a great one to feel free to go back and rewatch. All right, let's keep moving. Moving in now to example 4, which I've taken the liberty of basically drawing out the whole thing. All right, so example 4, everybody turn with me. We're on page 99 doing the check it out number 4, but I basically wrote in all the info that you're going to need. Okay, so the question states you have triangle DEF, as I state right here. They give you the vertices. All right, vertices, that's where 2 lines meet. All right, so 2 lines meet, basically creating a corner. All right, and it's given as a point. So you have triangle DEF. Those are the vertices. D is 0, 0, E, -6, 0, F, 0, -4. Okay, now they tell us in the question that DEF is similar to triangle DGH. All right, so if we know that they're similar, if you look back in the notes, that tells us that all their angle measurements are now equal, and their side lengths must be in proportion, which is key. Now let's take a look at something else that we should see. You should see, take a look at that notice. They share vertex D, meaning both of these triangles will share the point D, which is 0, 0, otherwise known as the origin. Okay, now if they both share that, that lets us know that that's kind of a common point where they will both meet. All right, so then we are given that G is -3, 0. Please follow along with the colors. I wanted to make sure that it was easy to kind of tell the difference here. Okay, so DEF is in blue. Take a look at the triangle in blue. Then you have DGH in green. Now I've already finished the whole problem, but you just need to figure out what is the proportion. Okay, take a look at D, which if I could, I can go ahead and write in this right here is D. All right, so that's the common point. And then if you go from D out to E, which is right here, that's 6 points away. Now take a look at that note right in the middle that says half. All right, now you can see that E, if we cut it in half, well, that's where G is at -3. So we now know our proportion is cut every point in half. Okay, so if we go down to F right here, which we know is at -4, cut -4 in half, and what do you get? -2. That is how these guys are related. That's why I underline -4 in red and I underline the -2 in red to show you that. And your answer is the drawing itself. All right, so drawing the first triangle, DEF, and then drawing the similar triangle, DGH, and they both have to be together. That's what the directions say on the same grid. Okay, all right, let's now move into the very last one, number 5 here. Check it out, number 5 on page 99. All right, so the question is 6-foot tall climber casts a 20-foot long shadow at the same time. That's key. Same time, what this tells you is that the sun is in the same location. Okay? If it were not at the same time, that shadow would be completely different, and this problem could not be a proportion problem, but it can be because it's happening at the instantaneous same moment. All right, so you got a 6-foot climber that casts a 20-foot long shadow at the same time equals a tree unknown height that casts a 90-foot long shadow. And now, with the simple way of solving proportions, you just cross multiply. 20x equals 540. Divide both sides now by 20 so that we can isolate x, and x equals 27. All right, that is the height of the tree. All right, guys, that's what I got for you. Take it, use it, remember it, learn it. You guys got this, all right? Don't lose your motivation. Keep working hard. Ask questions if you got them. But the first thing is watching this video and maybe watching it twice. Do what you got to do, okay? I'll see you guys in the next one.